Let's say I'm trying to judge how many years of experience we have at the Khan Academy, or on average how many years of experience we have. And in particular, the particular type of average we'll focus on is the arithmetic mean. So I go and I survey the folks there. And let's say this was when Khan Academy was a smaller organization, when there were only 5 people in the organization. And I find, and I'm surveying the entire population, so years of experience, the entire population of Khan Academy, because that's what I care about, years of experience at our organization, at Khan Academy. And this is when we had 5 people. And I were to go, we're now 36 people. I don't want to date this video too much. But let's say I go and I say, okay, there's one person straight out of college. They have 1 year of experience, or recently out of college, somebody with 3 years of experience, someone with 5 years of experience, someone with 7 years of experience, and someone very experienced, or reasonably experienced, with 14 years of experience. So based on this data point, and this is our population for years of experience, I'm assuming that we only have 5 people in the organization at this point, what would be the population mean for the years of experience? What is the mean years of experience for my population? Well, we can just calculate that. Our mean experience, and I'm going to denote it with mu because we're talking about the population now. This is a parameter for the population. It's going to be equal to the sum from our first data point, so data point 1 all the way to data point, in this case, data point 5. We have 5 data points of each of, so we're going to take all from the first data point, the second data point, the third data point, all the way to the 5th. So this is going to be equal to x1 plus x, and I'm going to divide it all by the number of data points I have, plus x2 plus x3 plus x4 plus x sub 5, subscript 5, all of that over 5. And as we said, this is a very fancy way of saying I'm going to sum up all of these things. I'm going to sum up all of these things and then divide by the number of things we have. So let's do that. Get the calculator out. So I'm going to add them all up. So I'm going to add them all up. 1 plus 3 plus 5. I really don't need a calculator for this. Plus 7 plus 14. So that's 5 data points, and I'm going to divide by 5. And I get 6. So the population mean for years of experience at my organization is 6 years of experience. Well, that's, I guess, interesting. But now I want to ask another question. I want to get some measure of how much spread there is around that mean, or how much do the data points vary around that mean. And obviously I can give someone all the data points, but instead I actually want to come up with a parameter that somehow represents how much all of these things on average are varying from this number right here. Or maybe I will call that thing the variance. And so what I do, so the variance, and I will do, and this is a population variance that I'm talking about, just to be clear. It's a parameter. The population variance, I'm going to denote with the Greek letter sigma, lowercase sigma. This is capital sigma, lowercase sigma squared. And I'm going to say, well, I'm going to take the distance from each of these points to the mean, and just so I get a positive value, I'm going to square it. And then I'm going to divide by the number of data points that I have. So essentially, I'm going to find the average squared distance. Now, that might sound very complicated, but let's actually work it out. So I'll take my first data point. I'll take that data point, and I will subtract our mean from it. So this is going to give me a negative number, but if I square it, it's going to be positive. So it's essentially going to be the squared distance between 1 and my mean. And then to that, I'm going to add the squared distance between 3 and my mean. 3 and my mean. And to that, I'm going to add the squared distance between 5 and my mean. 5 and my mean. And since I'm squaring, it doesn't matter if I do 5 minus 6 or 6 minus 5. When I square it, I'm going to get a positive result regardless. And then to that, I'm going to add the squared distance between 7 and my mean. So 7 minus 6 squared. All of this is my population mean that I'm finding the difference between. And then finally, the squared difference between 14 and my mean, plus 14 and my mean. And then I'm going to find essentially the mean of these squared distances. So this, I have 5 squared distances right over here. So let me divide by 5. So what will I get when I make this calculation right over here? Well, let's figure this out. This is going to be equal to 1 minus 6 is negative 5. Negative 5 squared is 25. 3 minus 6 is negative 3. If I square that, I get 9. 5 minus 6 is negative 1. If I square it, I get positive 1. 7 minus 6 is 1. If I square it, I get a positive 1. And 14 minus 6 is 8. If I square it, I get 64. And then I'm going to divide all of that by 5. And I don't need to use a calculator, but I tend to make a lot of careless mistakes when I do things while I'm making a video. So I get 25 plus 9 plus 1 plus 1 plus 64 divided by 5. So I get 20. So the average squared distance, or the mean squared distance from our population mean is equal to 20. You might say, wait, these things aren't 20 away. Remember, it's the squared distance away from my population mean. So I squared each of these things. I liked it because it made it positive, and we'll see later it has other nice properties about it. Now, the last thing is, how can we represent this mathematically? We already saw that we know how to represent a population mean and a sample mean mathematically like this, and hopefully we don't find it that daunting anymore. But how would we do the exact same thing? How would we denote what we did right over here? Well, let's just think it through. We're just saying that the population variance, we're taking the sum of each. So we're going to take each item. We'll start with the first item, and we're going to go to the nth item in our population. We're talking about a population here. And we're not going to just take the item. This would just be the item. But we're going to take the item, and from that, we're going to subtract the population mean. We're going to subtract this thing. We're going to subtract this thing. We're going to square it. So the way I've written it right now, this would just be the numerator. I've just taken the sum of each of these things, the sum of the difference between each data point and the population mean, and squared it. If I really want to get the way I figured out this variance right over here, I have to divide the whole thing by the number of data points we have. So this might seem very daunting and very intimidating, but all it says is take each of your data points. Well, one, it says figure out your population mean. Figure out your population, figure that out first. And then from each data point in your population, subtract out that population mean, square it, take the sum of all of those things, and then just divide by the number of data points you have. And you will get your population variance.